All right, today we're going to be looking at yet another shortcut. This one is going to be sine and cosine complementary angles. Sine and cosine complementary angles. All right, first things first, you should already know this, but I don't want to assume anything. What does the word complementary mean? All right, complementary means that it adds up to, and you don't have to do it this way, you could just write down adds up to. I just feel like being a little artistic today. Adds up to 90 degrees. All right, so it adds up to 90 degrees. If two angles are complementary, they add up to 90 degrees. All right, so that's going to be very, very important for what we're doing today, or for a different way to cheat given a problem. All right, what I want you to do is I want you to draw two identical triangles. Take about 5 lines each. Two identical right triangles, I should say. All right, take about 5 lines each. All right, and we're going to label the angles. Say this is 35 degrees. This one is 55, obviously, if it has to be a right angle. So 35, 55. Then I want you to label the sides. If this is 11 and this is 10, what does the third one have to be? Remember, a squared plus b squared is c squared. So 10 squared is 100, 11 squared is 121, so 121 plus 100 is 221. So this has to be the square root of 221. In order for it to be a right triangle, a squared plus b squared must be c squared. All right, so go ahead and label that on both triangles. They're going to be the exact same triangle. All right, perfect. All right, also we're going to need 3 old angels. So 3 old angels sitting on high, and what are they doing? Chatting about heaven. All right, 3 old angels sitting on high, chatting about heaven. So again, we're talking about sine and cosine complementary angles. That means that they add up to 90, but I need to show you how that's going to work. Now, I kind of took up all the space that I need to write the example for here, so I'm going to write it down here. So we're going to take a look at the first triangle, and we're going to cross out the 55, not because I don't want to use it, but because I don't want it to confuse us. On the second one, we're going to cross out the 35, okay? So we're going to write down the sine and cosine ratios of this triangle using 35 and 55. So on the first one, first thing I always do is label my triangle. So if I'm using 35, all right, 10 is going to be what? O. Radical 221 is going to be H. Whatever is left over is A. Label this triangle. This time your angle is 55, so that's going to be O. That's still going to be H, and that's going to be A. All right, so now we're going to write down the ratios, the ratios of these two triangles, the sine and cosine ratios, actually. And what I'm going to do is this. I'm going to separate just so that I leave a little room. So this work is going to go right here. The work for this one's going to go right here. All right, so let's start with, it doesn't really matter, but let's start with sine. Sine of 35 is equal to, now sine, all right, 35, so I'm looking at this first one. Sine is opposite over adjacent, so hypotenuse, sorry. Opposite over that, so it's going to be 10 over radical 221. All right, so sine of 35. What the complementary angle says, remember complementary means it adds up to 90. What the complementary angle says is sine and cosine are complementary. So sine and cosine are complementary. So notice I'm writing on the bottom, so I'm going to be doing this one actually. What do I need for this to be 90? Because I'm saying sine and cosine are complementary when they add up to 90. So if this is 35, and I want to find out what is cosine of the balance to add up to that. So what is cosine of 90 minus 35? All right, so what is cosine 90 minus 35 is 55. So notice, okay, 90 minus 35 is 55. So if I find cosine of 55, we are going to see a relationship between this complementary angles of sine and cosine. So cosine of 55 is congruent to, or is equal to, I'm sorry. So cosine. Cosine is using A and H. So A is 10, because now I'm using 55, right? 10 and radical 221. What can you tell me about sine 35 and cosine 55? They're the same because sine and cosine of complementary angles are the same. In other words, if the sine and cosine adds up to 90, so 35 plus 55, those two ratios are exactly the same. All right, let's take a look at cosine of 35 and compare it to sine of 55. So cosine of 45 and compare it to sine of 90 minus 35, because again, remember, complementary adds up to 180, to 90. So sine of 55. Let's see if those two ratios are the same. And according to this shortcut, they will be. So cosine is A over H. A is 11, because it's cosine of 35. 11 over radical 221. All right, and I'm saying that that's going to be the same as sine of 55, as the complement angle or sine. So sine of 55, so here's 55. Sine is O over H. O is 11. H is radical 221. All right, are they equal? Yes. All right, so again, sine of 35 is the same as cosine of 55. Okay, and then cosine of 35 is the same as sine of 55. In other words, sine and cosine of complementary angles are equal. All right, so let's take an example. So right underneath that, take an example. Example 1. All right, given sine of 57 is equal to 0.839, find the complementary angle. All right, so remember, sine and cosine are complementary, okay? And they're complementary angles, they're equal. So sine of 57 is the same thing as saying cosine of 90 minus 57, and that's going to be equal to sine of 57, so 0.39. So cosine of 90 minus 57 is 33. So cosine of 33 is 0.839. All right. And that's it. That's all there is to this question. So it's just a quick shortcut to recognize, okay, sine and cosine are complementary. Let's take a look at another example. So example 2, given cosine of 60 is 0.5, find the complementary angle. So again, you know cosine of 60 is 0.5, so sine of whatever adds up to 90 with 60, so it's sine of 30, but I'll just go ahead and show work. 90 minus 60 is also 0.5. So sine of 90 minus 60 is sine of 30 is also 0.5. All right, so this is a really good shortcut that helps you with problems where you don't have to work it completely out, where you could just use this shortcut to recognize the relationship.